s orbital. Only one energy level, only s orbital. If you have something like carbon that has second energy level, 2s and 2p, two types of orbitals. If you have third energy level entry, then it can have 3s, 3p, 3d. It means if n is equal to 1, L can be only 0. That is only you can have 1s. If n is equal to 2, if the valence electron is in second level, L can be either 0 or 1. It means it can be 2s orbital or 2p orbital. If n is equal to 3, the L value can be either 0, 3s, or 1, 3p, or 3d. Suppose n is equal to 4, what could be the possible values of L, sir?
0, 1, 2, 3.
It can be 4s, it can be 4p, it can be 4d, it can be 4f, right? Yes, sir?
Yes, sir. Yes, sir.
Can I have 2d orbital?
No, sir.
Because if n is equal to 2, L cannot be equal to 2. That's the reason why. In sulfur, valence shell is number 3. So it has empty 3d orbitals. Hence, sometimes sulfur uses 3s, 3px, 3py, 3pz, 3dx square minus y square orbitals for intermixing to get 6 hybrid orbitals. You should ask me a question. Can you ask me a question now?
Sir, why 3dx square minus y square?
Perfect. I have taken only 3dx square minus y square out of 5 possible d orbitals like 3dz square, 3dx square minus y square, 3dxy, 3dyz, 3dzx. Of these I have chosen only this. Why? Because px, py, pz are lying on the axis. Can you see? Yes. Now the d orbitals that lie on axis are either dx square minus y square or dz square. All other d orbitals, dxy, dyz, dzx, they lie in between the axis. It is easy to intermix the orbital which is lying on the axis along with px, py, pz. It is easy to intermix the orbital which lies on the axis. So I have taken dz square, dx square minus y square. I can also take dz square. Are we clear about it?
Sir,
Hello?
I joined now, sir. What you told me?
What did you say?
I joined now only, sir.
What can I do, sir? You could have joined in time, right? Now we are pointing out that sulfur can use its valence 3s, 3p, 3d orbitals, one 3s orbital, one 3px, one 3py, one 3pz, one 3dx square minus y square orbitals for intermixing. 1, 2, 3, 4, 5. When 5 orbitals are intermixing, but not 5, 1, 2, 3, 4, 5. Let's add one more 3dz square. 3dz square. Why you have taken only 3dz square and 3dx square minus y square means only these d orbitals are lying on the axis. Px, py, pz anyway are lying on the axis. So if I intermix these orbitals, how many orbitals I am intermixing? 1, 2, 3, 4, 5, 6. So I get how many hybrid orbitals, sir? Number of hybrid orbitals produced is equal to
Number of
sigma
orbitals.
of atomic orbitals intermixing. Yes or no? Yes or no?
Yes, sir.
So here I got 6 sp3d2 hybrid orbitals. These sp3d2 hybrid orbitals have how many numbers, sir? How many?
6.
Out of 6, 1 is s orbital, so it has 1/6 s character. 2 are d orbitals, 2/6 d character, and 3 out of 6 are p orbitals, 3/6 p character. It means 16.66% s character, 33.3% D character, 50% P character. Okay, sir? Hello?
Okay, sir.
Now the sp3d2 hybrid orbitals are 6 in number. How all these 6 will arrange themselves? You draw a straight line, it is very easy, you learn how to draw. Draw a straight line, can you draw using your scale or using your free hand? Just draw a straight line. Draw a little smaller line. Draw still smaller line. This must be bigger. This must be smaller. This must be very small. Now if you join the ends, or you can draw the orbitals if you want. Should I draw the orbital? One sp3d orbital lying above and below. Right. Now if you join the ends, what is this shape, sir?
Square
What is this
bipyramidal.
shape? Octahedron. The shape is called what, sir? Octahedron or square bipyramid. Can you see that shape? It is a square. It is a pyramid. Square bipyramid, or it is called octahedron. It has 8 faces and 6 corners. 1, 2, 3, 4, 5, 6. Can you see it clearly? It is an octahedron. It has 8
Yes, sir.
faces and 6 corners. Now here is the sulfur atom. Each orbital has 1 unpaired electron, because sulfur has total how many electrons, sir? Sulfur in the valence shell has 6 electrons. The hybrid orbitals are filled according to Hund's rule.
Assalamualaikum, sir.
Excuse me? Excuse me? Hello? Salam alaikum, you said. I'm talking something, you are talking something else. Kindly look at, sir. The sulfur has 6 electrons in the outer level. All the 6 electrons are arranged in the hybrid orbitals according to Hund's rule and Pauli's principle. According to Hund's rule, one electron goes into each orbital. Unless each orbital gets one electron do not get paired up. So all the 6 hybrid orbitals have 6 electrons. Now, these 6 hybrid orbitals, each having 1 electron, are overlapped by p orbitals of fluorine. What is this molecule, sir? What is this molecule? It is SF6. What is this molecule? SF6. What is the shape of SF6?
Octahedral.
And what are these angles? Any 2 angles are 90 degrees. SF6 is such a beautiful, symmetric, stable molecule. Even at 1500 degrees centigrade, it will not dissociate. It is stable even at 1500 degrees centigrade. In your transformers, have you ever seen a transformer? Electric transformer?
Yes, sir.
In transformers, SF6 is used as gas phase insulator. Because of its extraordinary stability, it is used to prevent, short circuiting. SF6 is very stable because of its symmetric structure called octahedron. It is octahedron because of sp3d2 hybridization. Are we very clear about it, sir?
Yes,
Hello?
sir.
Now, let us look at the sp3d2 hybridization. What is the shape of sp3d2 hybrid orbitals? Once again, I try to draw here. Let us use black color. See, in between, so many fellows are joining. What is the shape, sir? What is the shape, gentlemen? Hello?
Octahedron.
In this octahedron, let us look at the case of BrF5. Bromine, whose configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p5, 4d0. So your bromine makes sp3d hybrid orbitals. Out of 6 sp3d hybrid orbitals, it has how many electrons, sir, in the valence level?
7.
7.
No, it is not clear to it is 4s2, 4p5. It has 7 electrons. Now I want to put 7 electrons, sir. According to Hund's rule, this orbital gets 1, 2, 3, 4, 5, 6, 7 electrons. Have you noticed one of the hybrid orbitals got electron pair? No, it cannot be involved in bonding. Yes or no? Hello?
Yes, it is a
Yes, sir.
lone pair.
It is a lone pair. Now, because that is a lone pair, now it is making a bond. Here the Br is combined with F, 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 F. Due to sp3d2p overlap. It is called sigma sp3d2p bond. Now, the lone pair will not contribute anything to shape. So you should forget about it. What is the shape of the molecule, sir?
Square pyramid.
It is looking like this. It is a clean square pyramid. Can you see it, sir? Yes?
Yes, sir.
Therefore, in octahedron, if one position is lone pair, it will be square pyramid. To illustrate the point again, I am showing you, sir. In this octahedron, if this is a lone pair, you should forget about it. The shape remain what, sir? Square pyramid. Example is BrF5. It is F, 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 F. Yes, sir. Hello. So the shape of the molecule is square pyramid. Now let us look at another case. Again, I am drawing the. What is the shape I am trying to say, sir? What is the shape? What is this, sir?
Octahedron.
In this octahedron, there is one lone pair, means it became square pyramid. Now, if I look at a molecule like XCF4, xenon also uses sp3d2 hybrid orbitals, but xenon in the valence shell has 8 electrons. If I have 8 electrons, how can I put 8 electrons? 1, 2, 3, 4, 5, 6, 7, 8. So these two positions are lone pairs. Here there is xenon. Here we have fluorines. What is the shape, sir?
Square planar.
It is square planar. Therefore, I noticed that in octahedron, if all positions are making bonds, it is octahedron. If only 5 positions are making bonds, if there is one lone pair, that is square pyramid. If only 4 positions are making bonds with 2 lone pairs, that is square planar. Can we see?
Yes, sir.
So the lone pairs bring about a variation in the shape, though the central atom is undergoing sp3d2. Now there are two questions. In SF6, how the electron pairs are arranged on the central atom, what is the shape? In SF6, electron pairs on the central atom arranged octahedrally, shape of the molecule is octahedron. How the electron pairs are arranged around the central atom in BRF5, what is its shape? Electron pairs are arranged octahedrally because hybridization is sp3d2, but because one position is lone pair, shape of the molecule became square pyramid. How the electron pairs are arranged around the central atom in xenon in XeF4, what is its shape? In XeF4, hybridized state is sp3d2, octahedral arrangement of electron pairs, but because two positions are lone pairs, the shape of the molecule became square planar. Are we clear on this, sir?
Yes, sir.
See, total 6 electron pairs. In AB6, all are bond pairs. All are bond pairs. Shape is octahedral. In AB5E1, 5 are bond pairs. 1 is lone pair. Shape is square pyramid. Can you see that?
Yes, sir.
In AB4E2, 4 are bond pairs, 2 are lone pairs. Shape is simply square. Can you see that, sir? Hello?
Yes, sir.
Now, what is the total number of electron pairs on the central atom? In this case, 6. In this case, also 6. In this case, also 6. Can you see that?
Yes,
Yes,
sir.
sir.
Here, all the 6 are bond pairs. Here, 5 are bond pairs, 1 is lone pair. Here, 4 are bond pairs, 2 are lone pairs. But the central atom, number of electron pairs on the central atom is only 6. Yes or no? If the electron pairs on the central atom are 6, hybridized state must be sp3d2. Because sp3d2 hybrid orbitals are 6. Are we very clear? Hello?
Yes,
Yes,
sir.
sir.
Let us suppose if the central atom has 5 electron pairs. 5 electron pairs can be accommodated in 5 hybrid orbitals. What is that hybridization that gives 5 hybrid orbitals?
sp3d.
P3D1.
And in phosphorus, if I look at configuration 1s2, 2s2, 2p6, 3s2, 3p3, 3d0. So a 3s orbital, a 3px orbital, a 3py orbital, a 3pz orbital, and a 3d z square orbital, any one. 3d z square, 3d z, 3pz, 3py, 3px, 3s. If these 5 are, why I have chosen only 3d z square? Why not 3d xy? Out of 5 d orbitals, dz square, dx square minus y square, dxy, dyz, dzx. For hybridization, I use dz square, but not dxy, dyz, dzx. Why only dz square, sir?
Because it
Hello.
has dumbbell shape and they have
Every d
double dumbbell.
orbital has dumbbell shape, man.
It lies
Lie
on
on
the
the
axis,
axis.
sir.
The dz square and dx square minus square, only these two lie on the axis. The dxy, dyz, dzx lie in between the axis. For intermixing, p orbitals are lying on the axis. So it is more appropriate for a d orbital which is also lying on the axis to involve in hybridization. Hence I have chosen dz square. Okay, sir? For s orbital, you have no go. It is spherical and there is no other way. So how many orbitals are intermixing? 1,
5.
2, 3, 4, 5. Number of atomic orbitals intermixing is equal to number of hybrid orbitals produced, 5. The 5 orbitals arranged like, what is this shape? These are called equatorial, separated by 120 degrees. These are called axial. Angle between axial and equatorial is how much, sir? How
90.
much?
90.
How much? 90.
90.
So these are sp3d hybrid orbitals. They have 1/5 s character, 3/5 p character, 1/5 d character, 20%, 60%, 20%. And the shape of the molecule is trigonal bipyramid if all are making bonds, as in PCl5. In PCl5, this is making overlap with CLP orbital, sigma sp3d p, sigma sp3d p, sigma sp. So what is the shape of PCl5, sir? What is the shape of
Trigonal
PCl5?
bipyramid.
Tonal by
No issue. If all are bond pairs out of 5, electron pairs are 5, bond pairs are 5, lone pairs are 0, it is AB5, hybridization is sp3d, shape is trigonal bipyramid, PCl5. Let us suppose out of 5 electron pairs which are arranged like trigonal bipyramid, there is one lone pair, 4 bond pairs on. Where do you think lone pair will go? Will it go to axial position or will it go to equatorial position? Where it will go?
axial.
Sir, the angle between the
Equatorial.
axial positions and other positions is 90. The angle between the equatorial positions is 120. Lone pair wants to occupy a space which is more free and apart from others. So it definitely prefers what position?
Equatorial position.
Equatorial.
If that equatorial position is occupied. Are we very clear? Okay, sir? Now let
Yes,
us
sir.
draw
Yes,
the
sir.
diagram. These are axial positions. These are equatorial positions. You are saying lone pair will occupy equatorial position. Yes, sir? Yes?
Yes, sir.
That is equatorial.
Yes, sir.
I made the trigonal bipyramid to lie on the ground. Axial, equatorial, equatorial, equatorial. This is occupied by lone pair. Okay, sir? In SF4, SF4, sulfur uses sp3d hybrid orbitals, but only the sulfur the sulfur has how many electrons, sir? 6. How many are there? Do you know sulfur has 6 valence electrons?
Yes, sir.
Oxygen, sulfur, selenium, tellurium, all they have 6 valence electrons. They are in the 16th group. They are called chalcogens. The 6 electrons, how do you arrange, sir? 1, 2, 3, 4, 5, 6. So in SF4, sulfur is using sp3d hybrid orbitals. And when I distribute these 6 electrons in these 5 orbitals, one became lone pair. That lone pair will not contribute anything, but each sp3d orbital that has 1 electron overlap with the fluorine to give a sigma sp3d p bond. So these are fluorines. And this is your phosphorus. Let us use this color. Sir, what is the shape of this molecule, sir? What is the shape, sir? The lone pair you should forget. It
Seesaw
won't
shape.
contribute anything. What is the shape?
Seesaw shape.
Seesaw. Can you see the shape? In a trigonal bipyramid, if one position is lone pair, then the shape of the molecule becomes a seesaw. SF4. Are we clear on this, sir? Hello?
Yes, sir.
Now I have another question. Suppose if there are 2 lone pairs in the same, where the second lone pair will go, sir?
Equatorial position.
So it will go here. As you see in ClF3. In ClF3, Cl is the central atom. The fluorine, chlorine, bromine, iodine, all they have 7 electrons. 7 electrons, how can I arrange? 1, 2, 3, 4, 5, 6, 7. It means there are 2 lone pairs. Here is a lone pair. Here is let us use this color for lone pair. Okay, here is a lone pair. Here is a lone pair. And it is your Cl. And these are fluorines. What is the shape, sir, now? What is the shape?
T shape.
Notice this is coming towards you. It is coming towards you. It is like this. Can you see it really? Hello?
Yes,
Yes,
sir.
sir.
Can you see? In trigonal bipyramid, where the central atom is using sp3d hybrid orbitals, if there are 5 electron pairs, the shape is trigonal bipyramid. But if there are only 4 bond pairs, the shape is seesaw. If there are only 3 bond pairs, if there are 2 lone pairs, the shape is T. Agreed or not? Hello? Agreed?
Yes, sir. Agreed.
Now let us suppose there are 3 lone. Where the third lone pair will go, sir?
Equatorial position.
If the third lone pair is going here, if you take XeF2, xenon is using sp3d hybrid orbitals, but xenon has 8 electrons in the valence shell. 8 electrons are arranged like 1, 2, 3, 4, 5, 6, 7, 8. So now the equatorial positions all are occupied by lone pairs. Now this xenon, I use which color? Okay, blue color. Xenon is making XeF2. Now what is the shape, sir?
Linear
What
shape.
is the shape? So if there are 3 lone pairs, that is linear. If there are 2 lone pairs, that is T shape. There is 1 lone pair, that is seesaw shape. If there are no lone pairs, that is trigonal bipyramid. Can you see it really? Hello?
Yes, sir.
Yes, sir.
I want you to see it. Don't try to muck it off. There are 5 electron pairs. All are bond pairs. What is the shape, sir?
Trigonal bipyramid.
It is trigonal bipyramid. If one fellow is a lone pair, what is the shape, sir?
Seesaw.
Seesaw.
Seesaw. If 2 fellows are lone pairs, what is the shape, sir?
T shape.
If 3 are lone pairs, what is the shape, sir?
Linear.
Linear.
I will write here TBP, seesaw, T-shape, linear. PCl5, PF5, SF4, ClF3, XeF2. Yes, sir. Fine.
Yes, sir.
Sir, SF6, all bond pairs, shape is octahedral. sp3d2 hybridization. In the same sp3d2, if there are 5 bond pairs, 1 lone pair, what is the shape, sir? Hello.
Square pyramidal.
Square pyramid. Example is BRF5. And in this 6, if 4 are bond pairs, 2 are lone pairs, what is the shape, sir?
Square
Plan.
shape.
Square planar. sp3d2 hybridization. And that example was XCF4. Yes, sir?
Yes.
Now let us draw a line here. And now if the hybridization is sp3d, as in PCl5, all 5 are bond pairs, 0 lone pairs. Same sp3d, 4 are bond pairs, 1 is lone pair. An example was given as SF4. Yes, sir? And what is the shape, sir?
First one,
It is
trigonal by
2D. It is seesaw. Seesaw. You have seen or something like seesaw. It is the seesaw where 2 children can play, 2 children can sit and they balance. Right? Yes, sir? Suppose in the same sp3d hybridization, 3 are bond pairs and 2 are lone pairs. What is the shape, sir?
T.
T shape.
And example was CLF3. In that sp3d, if 2 are bond pairs, 3 are lone pairs. What is the shape, sir?
Linear shape.
Example
Example
was,
STF2.
are we very clear about this, sir?
Yes, sir.
So, in octahedron, you introduce lone pairs. In trigonal bipyramid, you introduce lone pair. Next, sp3 hybridization. Carbon you can see undergo 1s2, 2s2, 2p, x1, y1, z0. Excited carbon 1s2, 2s1, 2px1, y1, z1. It uses all the 4 orbitals 2s, 2px, 2py, 2pz. You got 4 hybrid orbitals. How are these 4 hybrid orbitals, sir? How they are separated?
Tetrahedron.
109 degrees, 28 minutes. If each such hybrid orbital, how many electrons carbon has? 4. 1, 2, 3, 4. So each fellow overlaps with hydrogen s orbital. Happily you got methane. What is the shape of methane, sir? Hello.
Tetrahedron.
What is the shape of methane? Tetrahedron. Bond angle is 109 degrees, 28 minutes. So carbon atomic number 6, it has 4 valence electrons. All are involved in bonding. Smooth story. Okay, sir? Okay, sir. Okay?
Okay, sir.
Now, sir, nitrogen atomic number 7 has a configuration 1s to 2s to 2px1 y1 z1. If nitrogen also undergoes sp3 hybridization, how many hybrid orbitals I get, sir? 4.
4.
Now, how many electrons it has?
5.
1, 2, 3, 4, 5. Therefore, if it is a lone pair, it is not involved in bonding. Now it can combine with hydrogen, hydrogen, hydrogen. What is the shape of this, sir?
Trigonal planar.
No. Is it in a plane? Sir, it is TD, sir. It is tetrahedron, sir. In this tetrahedron, you are removing this part. It is not in one plane. It is not in one plane, sir. What is this shape, please?
Square.
Trigonal pyramidal.
It is called trigonal pyramidal. It is pyramid. It is 3D. Normally, this angle is supposed to be 109 degrees 28 minutes. But because there is a lone pair which occupies more space, these electron pairs come close. So this angle is less than 109 degrees. It is degrees 28 minutes. In ammonia, H and H bond angle is compressed to 107 degrees because lone pair is occupying more space. Because lone pair bond pair repulsions are more than bond pair bond pair. Do we know this, sir? Hello?
Yes, sir.
Sir, there is an interesting question. In ammonia, how many electron pairs are there on central atom? 4. How the electron pairs are arranged? Tetrahedrally. But how many of them are bond pairs? Only 3. Because there are only 3 bond pairs, what is the shape? Trigonal pyramidal. Can you understand this?
Yes,
Hello.
sir.
So this question can be tricky. In ammonia, how electron pairs are arranged around central atom means you should say tetrahedral. What is the shape of ammonia molecule? You should say trigonal pyramid. You understand the difference?
Yes, sir.
Hello? That's very, very intricate IIT mains question. Let us take last example before we close. All of you please pay attention. sp3 hybridization, what is the shape, sir?
Tetrahedral.
And you know, in sp3 hybrid orbitals, 1 out of 4 is S, 3 out of 4 are P. It means it has 25% S character, 75% P character. Can you see it clearly? Hello?
Yes, sir.
Suppose oxygen which has a configuration 1s2, 2s2, 2p4 makes sp3 hybrid orbitals. How many electrons it has?
6 valence electrons.
6 electrons in valence shell. 1, 2, 3, 4, 5, 6. How many lone pairs it has, sir?
2 lone pairs.
2 lone pairs.
2 bond pairs.
So it can make only 2 bonds. These are lone pairs. Let us not worry about